Hello everyone, welcome to Manufacturing Processes and Materials MET 200. This is the first session of this course, and we will be talking about general introduction to manufacturing. In this lecture, we will be answering some of the important questions like what is manufacturing and how is it organized in industry, and what are the material and processes and systems by which it can be, accomplished. Making things has been essential human activity since ancient history, and today the term manufacturing is used for this activity and for technological and economical reasons. Manufacturing is very important to United States and most other, developed and developing nations. What is manufacturing? Actually, the word manufacture is derived from two Latin words, manus, hand, and factus, which means, make. And the combination means, made by hand. Now we have many modern manufacturing operations that can be accomplished by automated equipment, and it can be supervised by human worker. Manufacturing can be defined in two ways. One is technological, and the other one is economical. For the technological, it means the application of physical and chemical processes to alter the geometry, properties, and the appearance of a starting material to make parts or products. As you see in this schematic, we have a starting material on the left, and then we have tools, machinery, or power and labor, which are inside the manufacturing process, and the output is going to be processed part, and we have some waste material and scrap, and some of them can be reused. For the economical reason or economical point of view, the key point in the manufacturing is that it adds value to the material. When you change them, alter the shape of the material. For example, in this schematic, on the left side, you have a starting material, and then you process the material, you change, the shape, and then you have a process part. So the process part has, added value. It has, greater value comparing with the starting material. Here is one good example about the economical point of view in the manufacturing processes. On the right side, we have a starting billet, starting titanium billet, and the left side we have the artificial heart valve that can be used, for patients who have a heart problem. And the left part actually worth thousands of dollars because of the manufacturing processes that has been done on that part. The black part on this component is a wafer, a carbon wafer. Probably the machining, depending on how much time is used to make the part, so the cost is going to be higher. For example, for this one, I can guess the minimum machining time would be 1 hour. The CNC machining. CNC is a computerized, machining processes. Manufacturing industry actually consists of enterprises and organizations that produce or supply goods and services. And they can be classified as three main categories. First one is the primary industry, where they cultivate and exploit natural resources like agriculture, forestry, fishing, and livestock, mining, petroleum. And the second industry, they take the output of the primary industry and then they convert them into consumer or capital goods, including electric power generation, aerospace, automotive industry, basic metals or beverage, chemical, computer, construction, any equipment or food processing. These are some of the secondary industries. And the tertiary industry, which is a service sector, some of them can be banking or education, tourist, restaurant. These are the third industry. And this, as you see, manufacturing includes several industries, and all of them are not covered in this book or lecture. For our purposes, manufacturing means productions of hardware, such as nuts, bolts, car, airplane, computer, plastic parts, and etc. Manufactured, products actually are divided in two classes, two major classes. One is a consumer product. Those are purchased directly by a consumer. Example can be a car, clothes, tennis racket. And the second products are the capital products, which are purchased by company to produce and again products or provide service. Examples are aircraft, trucks, machine tools. These are some examples, some products that are used to make another product. When we are producing parts, we are dealing with the four different type of material. Three are the main elements, like metal, ceramic, and polymers, and their chemistry are different. Their mechanical property and physical property are completely unique. But recently, one new material was developed, is called composite, which is a mix of these three material: metal, ceramic, and polymers. This is the a classification of all engineering material we have. For example, we have metal, as I said before, ceramic, polymers, and composite, and each one is subdivided to other material, like ferrous metals. It can be iron, non-ferrous material, so aluminum, Al, and then we have crystalline ceramics, and then we have glasses under this category, ceramic. And polymers are divided into thermoplastic, thermoset, and elastomer. Each one has a unique property. And then we have a composite. The composite can be a mix of metal and polymers, and or it can be a combination of ceramic and polymer, or polymer with the other with a mix of metal and ceramic. As I mentioned before, we have metals, and metals has a lot of uses in manufacturing. And normally pure metal is going to be combined with other elements to make alloys. And we have two basic group, as I mentioned before: ferrous metals and non-ferrous metals. Ferrous metal, the primary component or element is iron. The combination of iron and with other element gives you a steel or cast iron. Then we have non-ferrous, as I mentioned before. It can be aluminum, copper, nickel, and silver. The reason they call this category ferrous, the other one non-ferrous, is that iron has a magnetic property, so that's why they call it ferrous. These materials are non-magnetic. They don't have a magnetic property, so that's why they call it a non-ferrous. The second category is ceramic, and ceramic can contain metallic elements or non-metallic elements, and the typical metallic element is aluminum, and the typical non-metallic elements can be oxygen, nitrogen, and carbon. When we add aluminum, for example, a metallic compound, to a ceramic, we can make a very abrasive compound like alumina, and it has a lot of use for abrasive purposes. And we can use we can add non-metallic elements like silica to make glasses. We talk about ceramics further later on in separate session. In polymer material, we have a lot of repeating structural units, and the unit is called MERS. And in the MER we have atoms that share electron to form a larger molecule. In the polymers, we have three type: the thermoplastic. The thermoplastic has a unique property. The property is that when you reheat the material, the molecular structure is not going to be changed so much. One of them is a nylon. The second type, we have a thermoset. When the original shape is transformed to a rigid structure, we cannot convert it back to the original shape. It's like baking a cake. So elements can be flours, eggs, and water. You mix them and then you bake it. Once you bake the cake, you cannot bring it back to the initial original elements like flours. If you want to keep that in mind, consider a cake as a good example for this category. The third one is elastomer, which has a significant elastic behavior. One example is in natural rubber material. The next material is composite. Composite is a material which is composed of different, several elements. Normally, the dominant element is called, a matrix, and the other one, the one we have, less amount, is called, fiber or, particles. A good example of, composite is a concrete reinforced with a steel bar. As you know, concrete cannot survive in the tensile loading, so we add, this steel bar to increase its resistance during, tensile loading or stretch. So far, we discussed 4 materials that we want to discuss. We want to cover in this course. The next part of this course is dedicated to manufacturing processes. In the manufacturing processes, actually, we have two different operations that are designed in changing the material, the work material shape, and with the intention of increasing the value of the work material. The first operation is called, processing, where we transform a work material from one state to another, and it can be geometry changes or property changes. One example is machining. We change, geometry. We change the shape of the part. For property, one example is a heat treatment, where we can change, the strength of a steel or other material. The assembly operation, we join 2 or more components to create a new entity. One example of assembly operation is joining, welding processes. This chart shows the classification of manufacturing processes. As I said before, we have 2 category processing operation, which is subdivided to shaping processes. Then in the shaping, we have a solidification process, particulate processing, deformation, and material removal. And the material removal, we can have machining, is one of them. Deformation can be rolling. And then we have a property enhancing process. One example is, heat treatment. We can manipulate the property like strength, yield, stress of steel or other material through heating and cooling steps. Then we have a surface processing operation, which is cleaning and surface treatment. And then we have coating and deposition processes. In the assembly, we have permanent joining, and then we have mechanical fastening. In the mechanical fastening, normally we call it non-permanent joining processes. In the permanent joining, we have welding, different type of welding, and then we have brazing and soldering, adhesive bonding, which we use glue to bond 2 or more material together permanently. And then we have threaded fastener in the mechanical fastening, or other type of permanent fastening methods. In the processing operation, we change the material shape, physical property, or appearance in order to add value. We have three category: shaping operation, where we change the geometry of a starting work material, and then we have property enhancing operation, which improve the physical property without changing the shape. And the third is a surface processing operation, which can deposit material on the surface of another material. We have 4 different shaping processes. One is called solidification processes. Then we have particulate processing. Then we have deformation and material removal processes, which I discuss these processes in the next slides. Solidification processes. In this technique, actually all material can be processed, like metals, ceramic, glasses, plastic, all of them. In this technique, actually material are going to be transformed into liquid or semi-fluid, and then they're going to be poured in mold cavity, or sometimes we need to use force to push the material into mold cavity, and then let them to solidify. It requires some a certain amount of time. Then the material will take a solid shape that is the same as the cavity. If we use metal for in this process, it's called casting. If we use plastic material, then it's called molding. Next one is particulate processing, where we use a raw material as a powder. Powder can be metal powder or ceramic powder, and then we compress the powder. We apply force, and then we heat them up into a certain temperature. The temperature has to be lower than melting temperature. It's called sintering process. Then the material becomes solid and has higher strength, similar to the solid material. The next process is deformation, where we use a significant amount of force to change the shape of material, and the force has to be more than the yield strength of the material we are dealing with. This is forging process. As you see on the left, we have a raw material located in the die, and then we use a force to deform the initial shape, and the mechanical property definitely will change throughout this process. The other process is called extrusion, where the material has to be ductile, and then the part is going to be forced through this nozzle, and then the part will take the shape of this nozzle. The nozzle can be circular, ellipse, any shape, depending on the design. And this process, these two processes are called metal working, and those material that we want to use in this application, in this processes, they have to have a good ductility process, property. Otherwise, they will break during metal forming process. Material removal process is another topic that we discuss in this course. The most common name for the material removal process is machining. Machining can be different. Turning is one of them. Turning is this process where the part is going to be rotated, and then we have a tool bit, this one, and the tool bit can travel this direction and this direction, and it removes material, and chip is going to be removed from the part. And the other process is drilling, where we have a drill bit that is going to make a hole in the solid part. The next one is milling. In the milling process, the tool bit is going to be rotated. It can be horizontally, or it can be rotated vertically, and the part is going to be fixed, and mostly tool is going to be moved in throughout the workpiece surface.